Well, in this video, we're going to focus on zeros of polynomial functions. For any polynomial function f and any real number c, if f of c is 0, then c is 0 for f. Let me take you back to factor theorem. If x minus c is the factor of f, then c is 0 for f. So let's have some examples. Let's start with the first one. The first example is given by 3 times x minus 5 times x plus 2 times x minus 1, and we're asked to find the zeros. So this whole expression is 0 if and only if one of the binomials is 0. If x minus 5 is 0, or x plus 2 is 0, or x minus 1 is 0. So x minus 5 is 0 if and only if x is 5, or x plus 2 is 0 if and only if x is minus 2, or x minus 1 is 0 if and only if x is 1. So 5, minus 2, and 1 are zeros of f. Let's proceed to second example. We do have a degree 4 polynomial, and we're asked to find the real zeros, and x to the power of 4 minus 1 is equal to 0. Can be expressed as a product of x squared minus 1 and x squared plus 1. So x squared minus 1 times x squared plus 1 is 0, and this can be expressed as x plus 1 times x minus 1 times x squared plus 1 is equal to 0, because x squared minus 1 is the product of x plus 1 and x minus 1. So this expression is 0 if and only if x plus 1 is 0, or x minus 1 is 0, or x squared plus 1 is 0. So x plus 1 is 0 if and only if x is minus 1. X minus 1 is 0 if x is exactly 1. But x squared plus 1 is always greater than or equal to 1, because the minimum value of x squared plus 1 is always 1. Then this expression can't be 0 at all. So minus 1 and 1 are the only zeros of f. So from this, you can generalize that any polynomial function of degree n has at most n zeros. Let's proceed to third example. We do have a degree 3 polynomial here, and we're asked to find its zeros. So let me write down the degree 3 polynomial first. X to the third minus 3x squared plus 3x minus 1 is equal to 0, and we can write down this one as x to the third minus 1 minus 3x squared plus 3x is equal to 0. So we need to fully factorize the whole expression to find the zeros, and I'm gonna group the first two terms together and second two terms together, and then I'm going to factorize this one first, and then I will factorize this expression next. So x to the third minus 1 is 0 when x is 1. Means if 1 is the 0 of this expression, x minus 1 is the factor of this one. So let's divide x to the third minus 1 by x minus 1, and we will have the quotient. Then we will express x to the third minus 1 by the product of the quotient and x minus 1, because x minus 1 is the factor of this one. Then I'm going to apply synthetic division, and I'm going to factorize just the degree 3 expression. So I'm going to write down the coefficients of the whole expression. 1 is the coefficient of the degree 3 term, but we don't have degree 2 and degree 1 terms, means their coefficients are 0. And I'm going to write down zeros. And minus 1 is the constant term. So let me write down minus 1 here, and I'm going to write down 1 here, because we just considered x minus 1 as a factor of this one. Then 1 is 0 of x to the third minus 1. So I'm going to write down here. Then I will consider 1, and 1 times 1 is exactly 1. Just I'm going to write down 1 here. So 0 plus 1 is 1. Then multiply 1 with 1, and it's going to be 1. Just write down here. Then 0 plus 1 is exactly 1. So 1 times 1 is again 1. Then I'm going to write down 1 here. So minus 1 plus 1 is 0. This is the remainder, since x minus 1 is the factor, and the remainder is 0. And this is the coefficient of the degree 2 term, and this one is the coefficient of the degree 1 term, and this is the constant term. So the quotient is x squared plus x plus 1, and the remainder is 0. Then x to the third minus 1 can be expressed as a product of x squared plus x plus 1 and x minus 1. And the next step is going to be factorizing minus 3x squared plus 3x. So you can factorize minus 3x from both terms, then minus 3x will be multiplied with x minus 1. So minus 3x times x is minus 3x squared, and minus 3x times minus 1 is just 3x. So you do have two expressions connected by subtraction, and x minus 1 can be factorized as a common factor of the whole expression. Then you can write down the expression as a product of x squared plus x minus 3x plus 1 and x minus 1. So this can be simplified as x squared minus 2x plus 1 times x minus 1 is equal to 0. And x squared minus 2x plus 1 is the product of x minus 1 and x minus 1, and you do have x minus 1 here. So this expression is 0 if and only if x minus 1 is 0, and x minus 1 is 0 if x is 1. So 1 is the only 0 of f. Thank you very much. I'll see you in the next video. Bye bye.